Hello class 9. Today we'll start a new chapter, that is chapter 4. Pressure in fluids and atmospheric pressure. So before we start pressure in fluids, we will discuss about pressure, and again before pressure, thrust. So thrust is the force acting normally on a surface. So if we apply a perpendicular force to a surface, it is called thrust. Since it is force, that's why its unit is Newton. SI unit of thrust is Newton. We can also write kgf, kilogram force. 1 kilogram force is equal to 9.8 Newton. Now moving on to the next topic, pressure. Pressure is equal to thrust by area. So when we apply normal force on an area, that is called pressure. The effect of thrust depends on the area of the surface. Here area means area of contact of the body. So pressure is thrust per unit area of the surface. Similarly, now the unit of pressure, so then 1 Newton by 1 meter square, which is also called 1 Pascal, given after the scientist name. 1 Pascal is the pressure exerted on a surface of area 1 meter square by the force of Newton acting normally on it. So pressure is the effect of thrust per unit area, that is called pressure. Pressure is, the unit of pressure is 1 Newton by 1 meter square, which is called 1 Pascal, given after the famous scientist who has done a lot of research regarding in this field. 1 Pascal is the pressure exerted on a surface of area 1 meter square by a force of 1 Newton acting normally on a body. Other units of pressure is 1 bar, which is equal to 10 to the power 5 Newton per meter square. 1 atmospheric pressure, which is equal to 760 torr. Similarly, so many other units are there for pressure. Now, what are the factors which are affecting the pressure? The two factors. From the definition, the area on which the thrust is applied and the thrust means the pressure. So it is direct from the formula. You can see it is thrust by area. So pressure is directly proportional to thrust. When thrust increases, pressure also increases. And the second point is the area on which thrust is applied. So it is inversely proportional to the area of contact. Okay. Now, here an example is there for thrust and pressure. So as you can see, a same block is there having different dimension, that is 10 centimeter into 15 centimeter into 5 centimeter. Okay. Placed on the base in 3 different ways. Okay, so we have to calculate pressure on the 3 different cases: case A, case B and case C. Same block placed vertically, horizontally. Okay, now for the first case, case A, we know that pressure is equal to force by area. Force is common in all the 3 cases, that is 1500 Newton given. So first calculate the area, which is given in centimeter. In the first case, it is 10 centimeter into 5 centimeter, as breadth is 5 centimeter, length is 10 centimeter. So it is 10 centimeter into 5 centimeter, which is 50 centimeter square. Now convert this centimeter to meter square. Now put in the formula of pressure. Force by area. Pressure is equal to. Hence 1500 Newton by 0.05 meter square. When we convert, we get 3 into 10 to the power 5 Pascal. First case I have solved. Second also I have solved for you. That is pressure is equal to force by area. Same force is same 1500 Newton. And here area is different. That is 10 into 15 centimeter. 10 centimeter into 15 centimeter, first calculate it, then convert to meter and substitute in the formula. So we'll get 10 to the power 5 Pascal. P3 I am leaving for you. Solve it. For the third case, here the area of contact is different, 50 Now we'll discuss about the ways to increase the pressure. And for that, the very simple way is that to reduce the area of contact, because it is inversely proportional to area of contact. Pressure is inversely proportional to area of contact. Pressure is equal to force by area. So if we want to increase pressure, we have to reduce the area of contact. The best example is just in front of your eyes, a sharp nail and a blunt nail. In sharp nail, the area of contact is less as compared to a blunt nail. So it is very much easy to apply more pressure on a sharp nail. Okay. Now the next is ways to decrease the pressure. And for decrease the pressure, what we will do? The pressure on a surface is reduced by increasing the surface area. The best example is in front of your eyes, as you can see, case A and case B. Here the same block with different area of contact, and hence the result is again in front of your eyes. You can see the pressure changes. In the first case, where the area of contact is 10 into 5 centimeter, the pressure is 3 into 10 to the power 5 Pascal. And the second case, where the area of contact is 10 into 15 centimeter, more area of contact, hence less pressure, 10 to the power 5 Pascal. So these are the ways to increase and decrease the pressure. Moving on to the next topic. Now we'll discuss about pressure in fluids. A fluid contained in a vessel exerts pressure at all points and in all directions. So as you can see the diagram here in front of your eyes again, and in this tube there are 3 holes, and in all the 3 holes the water is coming out. So the liquid here spouts out through each hole. This shows that the liquid exerts pressure at each point on the wall of the vessel. Now if we put our one finger on any one hole, finger feels a thrust due to liquid. This demonstrates that liquid contained in a vessel exerts thrust at all points below its free surface. Thrust on a unit area at a point gives the pressure due to liquid at that point. Now if we note the distance from the bottom of the vessel to the point where the liquid from the hole strikes on the horizontal surface, it is noticed that the depth of the hole below the free surface of the liquid increases. The throw of the liquid also increases. As we go down, the pressure of the liquid will increase. Now we will discuss the next topic, that is pressure exerted by a liquid column. Here we will calculate the pressure exerted by the liquid column. So first we will consider a vessel containing a liquid of density rho. As you can see the diagram in front of your eyes, let the density be stationary. In order to calculate the pressure at a depth h, consider a horizontal circular surface PQ of area capital A at the depth h below the free surface xy. The pressure on the surface PQ will be due to the weight of the liquid column above the surface PQ. Now I will calculate pressure with the same formula as we are doing in solid. In liquid also the same formula, pressure is equal to thrust by area. So very first we will calculate thrust, then we will substitute in this formula to calculate pressure. Now thrust exerted on this diagram. So thrust exerted on the surface PQ is the weight of the liquid column PQRS. Now we know that weight is mass into acceleration due to gravity. Now here we will substitute the formula of mass related to volume and density, as we all know that density is equal to mass by volume. Therefore mass is equal to volume into density. So the formula is, now it becomes volume into density into G. In place of M we have substituted here volume into density, V into rho. Now again volume is equal to length into breadth into height. In place of length into breadth we can write area, so area into height. So area into height in place of V we have written, and density and G as it is. So it becomes area into height into density into acceleration due to gravity. This is our thrust. Now substitute this formula of value of thrust in the formula of pressure. So pressure is equal to thrust by area. So AH rho G by A. So A cancel out, and hence we get the formula in a liquid column, which is pressure is equal to H rho G, the formula for pressure. From this, here the three factors are there on which the pressure depends. Very first, height H, density of the liquid, water, that is here in this diagram we have water, and G, acceleration due to gravity. So pressure depends on these three factors: height, density, and acceleration due to gravity. Now this is an example of a diagram related to the height, means depth here. So as deep we go, the pressure in the liquid column increases. So pressure increases with the depth. It is directly proportional to depth. So as you can see in the third hole of the jet, the pressure of the liquid is more because we are going deeper and deeper for the third hole. So pressure increases with the depth. First factors which affect pressure is the depth or height. As deep we go, the pressure increases. Next is density of the liquid. As pressure increases, density increases, or density increases, pressure increases. Directly proportional. And the last one, acceleration due to gravity, also it depends, directly proportional. So at a particular place on the earth's surface, the acceleration due to gravity G is constant. Therefore, the pressure at a point in a liquid is directly proportional to depth of the point below free surface and directly proportional to density of the liquid. Where G is constant, it depends on two factors, that is depth and density. Now, however, the pressure inside the liquid does not depend on number one, shape and size of the vessel on which the liquid is contained and the area of surface on which it acts. So it acts on only these three factors, and on the surface of earth, acceleration due to gravity is constant. So at that condition, it depends on only two topics, that is density and depth. Moving on to the next topic. Now some consequences of liquid pressure. Very first, there are many examples. First, which is here, that is the wall of a dam is made thicker at the bottom. As you can see in this diagram, the thickness of its wall increases from top towards the bottom. The reason is that pressure exerted by the liquid increases with its depth. Thus, as the depth increases, more and more pressure is exerted by the water on the walls of the dam. A thicker wall is required to withstand a greater pressure. Therefore, the wall of the dam is made with thickness increases towards the base. Now the next example is the diver's suit. The sea diver needs a special protective suit to wear because in deep sea the total pressure exerted on the diver's body is much more than its blood pressure. So to withstand it, he needs to wear a special protective suit made from the glass reinforced plastic or cast aluminum. The pressure inside the suit is maintained at 1 atmosphere.